Hi, so this video is going to show you on the derivation of this system, 2 degrees of freedom with assuming K2 and C2 is in tension. So we basically assume it that is in tension. So when it is in tension, we need to make sure we draw all the directions correct. So I already put the steps here. The first step is on how to draw the free body diagram. The first step is basically you need to assume direction of motion. So in this problem, we don't have to do that because you already have the assumed direction to the right. Both x1 and x2 are positive to the right. Then the second step is we want to determine the relative displacement. So basically in terms of relative displacement, we have to look at the first step. As we said, we already assume tension. So once we assume tension, so we draw for K2 and C2. So both of them are already in tension. Then the next step, you want to decide on which side gets negative. So what it means by that, you take a look at your side of x1, which is these two arrows, is opposite than x1. So in other words, that side should get negative. Okay. So, and if you look at the side of x2, it's actually same direction. So that side gets positive. So basically you are determining the direction who gets negative. So in this case, the x1 or n x dot 1 gets negative. Then you have to write, after you put the plus minus sign on each side of this spring and the damper, basically, the next step is to write the correct forces and moment on all the springs, not just that, but all the springs. So let us do first we've done with that, and we also need to make sure we do the that for K1 and K3. So maybe I write this one as K1 goes there because it has to get positive. K1 arrowhead and C1 arrowhead should be the same as X1 because we want to get positive. Same as K3 and C3, it should go to the right because X2 goes to the right. So you get positive direction. That's why I think I also pointed out in the notes, if you check your textbook, this is actually wrong, yeah, because it should have been in this direction later on when we draw the action reaction. So we have to write, before we write the action reaction, we have to make sure we write the correct forces in this case. So let me just go ahead and write all the forces first. Let me change the color. Okay, so I've write all the forces. So we are in step 2C. Basically, I've written all the correct forces of the spring and the dampers in purple. As I said, you have to see the directions just now, especially for K2 and C2. So I've written it in terms of x2 minus x1 because x1 gets negative. So this one, I've explained why it's negative, because it's opposite. The arrowhead of this is opposite than the direction of x1. Okay, so after that, we go to steps 3. Okay, which is drawing the action reactions. Maybe I use a different color to show that you do have action reactions there. So it goes to the left because these two goes to the right. Same as this one, is opposite. So it goes to the right. This one goes to the left because action reaction should be opposite and same forces. So you just write the forces once. So as I said, I've pointed out this is wrong in the textbook, so you may want to change that direction. then we can write the equation of motion based on M1 and M2. Okay, so we can actually draw now. We are now in steps 4, write the EOM for each masses. So don't forget that basically you just need to focus on M1. So after you've drawn the actual reaction, do not look at all the blue arrowheads. You are just focusing on this mass. So equation of motion is based on the mass itself. So you can write that equation. The way to write it is you have your M1 x double dot 1 equals to summation of forces, and your forces should be to the right as positive. You have to follow x direction of x1. Okay, so if you do that, you can write M1 x double dot 1 equals to, so now you have 4 forces there. Okay, if we include F1, okay, there is also a force there. Maybe for this one we just we assume no F1 and F2, so we don't have to write that. Okay, so K1 X1 all opposite direction to the left, so you get a negative C1 X dot 1 and negative K1 X1, and then you have K2 and C2 goes in the same direction, so you get plus. Okay, so when we actually write the equation M1 x double dot 1, so the C1 and K1 x1 all gets negative because it's opposite direction than x1, so this one gets positive because it's same direction as x1. Okay, so now we draw or write the second equation. So for the second equation, you just focus on M2. So there are also 4 forces there. So let us write for M2. Okay, so for M2, so you need to write on the masses M2 as in green. Then you can see all the forces are negative. So we have all the negative forces here. Okay. So then the next step is you just need to rearrange the terms and bring it to the left hand side of the equation and collect the terms. So if you do that, you can see that you can actually write it in this form for both of the equations. And if you have, let's say in this case, I assume F1, F2, 0. But if you have F1 and F2, you can actually rearrange the terms and get the term as very similar to what you have in your notes. So those are the steps that you can use basically on the how to draw the free body diagram and how to get the equation of motion. So after that, you rearrange the terms. So make sure you check out another video on how to get the same equation of motion but by assuming compression. So the main point here is it doesn't matter if you assume tension or compression, but you just need to follow the correct steps and the correct way of getting the arrowheads correct, and the way you write your plus minus on the forces, you have to write correctly according to the designated